Hi, welcome to Redox Reactions Part 5. My name is Dr. English, and today we're going to be talking about single replacement reactions and how they are involved in redox reactions. So specifically, we're going to look at, obviously, single replacement reactions, how a reaction can be spontaneous, the activity series, otherwise known as Table J of your reference tables, location, how to look at Table J and figure out whether a reaction is going to be spontaneous or not, how to use Table J one more time, a little review, and finally a little bit of practice at the end. So here's an overview of single replacement reactions. Single replacement reactions are going to have reactants that contain one free element and one ionic compound. That's how you're going to recognize them. And that ionic compound is going to be dissolved in water so our electrons can move. In a symbolic form, we can represent our one free element by this A right here and our one ionic compound by this BX right here. When a single replacement reaction occurs, A is going to basically replace the B, and the B will be kicked out by itself. The more active element will replace a less active element. We're going to refer to Table J in your reference tables to see how to figure this out. And all single replacement reactions are redox reactions. Metals will usually replace metals, and nonmetals will replace nonmetals. Let's talk about spontaneous reactions. So here we have a reaction, Cu plus 2AgNO3 yields CuNO3 plus 2Ag. This reaction is only going to occur in one direction, with the copper replacing the silver ion. So the copper coming in, kicking out the silver will then go into its elemental form, and the copper will form a compound with the nitrate polyatomic. This will not occur in reverse because silver cannot replace copper. We say silver is not as active as the copper metal is. Copper will lose its electrons to be more readily than silver, so therefore we say that copper is more active. The relative activity of metals is reflected in their abilities to replace one another from their compounds. A chart of element activity is a list that ranks metals and nonmetals according to their relative activity. A metal can replace only those metals below it in the chart. And the chart, of course, that I'm talking about here is Table J. And Table J is going to determine which metals are active and which metals are not as active. So let's look at Table J, this activity series. We're going to find that the most active metals are going to be found at the top left of the chart. So when we look here, these metals up here are going to be our most active ones. These metals that I've highlighted right here will oxidize or lose their electrons most easily. Your most active nonmetals are found near the top right side of the chart. Nonmetals will reduce or gain electrons most easily. So here we have our most active metals at the top and our least active metals at the bottom. And then only really 4 identified nonmetals that we might see in a single replacement reaction. We really need to look at this list and notice where the metals are located. Like I said before, your most active metals are going to be found at the very top, and they are found in groups 1 and 2. So looking at elements like lithium and potassium, strontium, and magnesium. These are all groups 1 and 2 metals. Your less active metals are going to be your transition metals, and we find them sort of in the middle. Your titanium or your iron or your nickel. We also have zinc and chromium, manganese. Then we have the metals that are below hydrogen, which is the standard by which all activity of other metals are based, and hydrogen is located right here. These will be our least active metals, in other words, otherwise known as the coinage metals, your copper, your silver, your gold. Let's look now at how to use Table J, a little reminder from what we learned before in chemical reaction. I'm going to look at the element copper, and copper is located right here. Here is copper. Copper can replace silver if silver was an ion in a compound in aqueous solution. Because copper is above silver, it can go down and replace it. Copper cannot replace magnesium. Here's magnesium way up here. Copper is too low on the list. So if copper went up and tried to replace magnesium, not going to happen, cannot happen. Copper can only replace those metals that are below it in this activity series. Let's look at another reaction. Zinc reacts with silver nitrate. So let's find zinc. Zinc is right here. And let's find silver. Silver's way down here. So the question is, can zinc replace silver? And the answer, of course, would be yes, because zinc is higher up on table J than silver is. Let's look at another example. Copper and potassium carbonate. All right, so let's find copper. Using copper a lot here. There's copper, and potassium is way up here. So do you think that copper can replace potassium? No, it cannot. Copper can only replace silver and gold. Any metal above it, it will not be able to replace. Let's look at our last example. Aluminum plus sulfuric acid. So where's aluminum? Here's aluminum, right here. And where's our hydrogen standard, which is right here? So can aluminum come down and kick out the hydrogen? And the answer is yes. Yes, it can, because aluminum is higher on table J than the hydrogen is. So this is a brief review of how to use table J to see if a reaction is spontaneous or not. Let's look at an old Regents question. According to reference table J, which metal will react spontaneously with Ag plus 1 ions but not with Zn plus 2 ions? All right, so we need some metal that can replace Ag, so it needs to be higher than Ag but lower than Zn. And we have 4 metals to choose from here. So let's go through and take a moment and highlight our Ag and our Zn. So here's Ag and here is Zn. We're trying to look for a metal that's in between these two. So the first one is copper. Where is copper? Well, copper is a definite possibility since it falls in between the two. But let's go look at our other possible answers. Gold is right here. Aluminum is, here's aluminum. And here's magnesium right here. Gold is not going to be the correct answer because gold cannot replace silver. So gold is not going to work. Bye-bye, gold. Aluminum will not work. Aluminum can replace both zinc and silver. We're looking for a metal right here that will not react spontaneously with zinc. And magnesium falls along those lines too. Magnesium would be able to replace both zinc and silver, and that's not what we're asking for. So our answer here would be Cu, because Cu has the ability to replace silver but cannot replace zinc. So what did you learn in this little tutorial? We went over the concept of single replacement reactions. We talked about spontaneous reactions. We looked at our activity series, our table J. We talked about metal location and how that influences whether something's going to be oxidized or reduced. We did a little review on how to use table J, and then we did some practice at the end. Need more help? Feel free to contact me. Have a great day.